Today, I'm going to talk to you about how we're using mathematics and GPS to understand how badgers move and why that's important for disease control. European badgers might look cute, but they play a big role in spreading a serious disease, tuberculosis, also known as TB. It affects cattle and can have a huge impact on farming. Now, we know badgers contribute to spreading it, but exactly how they move around and interact with each other, and how that influences disease transmission, is still a bit of a mystery. That's where this study comes in, aiming to model the badgers' movements. We used GPS tracking data from badgers that had been previously captured and collared for other studies, allowing us to create mathematical models to simulate and predict their paths. These models are based on energy use. From spatial data, we create an energy map to predict how badgers navigate their environment. To construct this map, we used a method called kernel density estimation, which transforms the GPS points into a smooth surface, highlighting where badgers spend most of their time. Although it is not a terrain map, you can still spot certain features where badgers avoid, such as the lake. In the model, the energy map guides where the badger is likely to go, like a ball rolling down a hill. But since movement isn't always predictable, such as during foraging, the model also includes some randomness to reflect unexpected behaviour or other influences. Then, we first use the model to simulate how badgers might move around in their environment and see if it matches with what we expect of their behaviour. Then we layered on a simple disease model to see how infections like TB could spread based on those movements. This means that if we want to control TB, say through badger vaccination or other means of management, we need to factor in their behaviour and movement patterns. It's not just about where badgers are, but how they move and when. Interestingly, when we analysed the random part of this model, it highlighted some patterns that match what has been seen in other studies, such as males move more than females, and there's also seasonal variability, which helps to support the model's reliability and also lays the groundwork for future research to make this model smarter. In the long run, this kind of work could help us make better decisions about wildlife management, attempt to reduce disease spread, and protect biodiversity and farming livelihoods. Thank you for listening.